Hello everyone, this is Rodrigo Uribe, and let me introduce you to basic concepts of observational studies and clinical research. First, let us step back and see where we are standing within the aims in clinical research. First, it is important to point out that clinical research studies overall will be divided according to the amount of controlled variables and manipulation of the population's exposure towards them. There's the experimental and quasi-experimental studies, which are not meant for this video, but it's good to know this is where exposure will be controlled or manipulated by investigators, whereas observational studies, it's quite the opposite. There will be no control or manipulation of exposure at all. And here you can see that we have different designs within the observational designs, such as case controls, case series, cross-sectional and cohort designs. Now, applying some of the concepts that have been defined in previous lectures, it is important to acknowledge that there is no better or worse study design whatsoever, but the most appropriate study or design towards the population being studied, the data that is available, and more importantly, the aims of the research questions that the investigators portray. Internal validity may not be a strong virtue in observational studies like it is in experimental designs, but external validity is one of the most or main attributes for observational designs. In other words, these results can be extrapolated to a real-world scenario where no control of exposure and independent variables will take place. The internal validity of observational studies can also be somewhat upgraded depending on the observational design, the sample size, statistical analysis, and mainly the selection bias of the study. And here we have the so-called levels of evidence pyramid, which intends to classify the quality of evidence in clinical research. Throughout this video, we will make use of this pyramid to identify which observational design we will address, avoiding to get lost along the way. A quite useful key concept for observational studies is to understand how data is obtained and how each design is determined in relation with time. Also, in how many periods of time are observations assessed and data is obtained. Cross-sectional design, like its name denotes, it's a section or a single slice of data observed through time. I like to use the analogy of photography, where we can freeze or petrify an event in time. This caption of an eclipse has enough information of the event in time for us to draw conclusions regarding the type of eclipse, which is by all means a lunar eclipse, but it does not provide us enough information to conclude if the lunar eclipse ended up being only partial, like in the picture, or it was a total eclipse. I mean, the period of time where the photo was taken may be enough for us to say a partial eclipse took place, but we cannot conclude that a total eclipse took place afterwards because we don't have the evidence for it. Having said this, a cross-sectional study aims to identify the prevalence or the current exposure towards the variable of interest within the population studied. Incidence and causality need more than one time observation to identify a condition that was first not present and then, within time, it was developed. Now, this photo portrays a traditional event happening in Alicante, Spain, where the habitants throw one another eggs, flour, and lots of fireworks around the downtown. This image will give us enough information to identify this period in time, we can get to count how many dark eggs and white eggs were not broken, or how many people was involved in the scene, but we cannot conclude if dark eggs were more resistant. We can also have unbalanced groups of eggs where there are more dark eggs than white. So any conclusion comparing color eggs will be affected by this imbalance that we have in this caption. But we can certainly describe the observed event in time, and the limitations or inconclusive correlations of this caption may lead to further research questions for subsequent studies. Cross-sectional studies are affordable without a need to invest a huge amount of time, and it can certainly estimate prevalences of an event, which means that it can estimate the prevalence of a disease in a specific population, and its results and limitations can be the aim for future studies with different designs to conclude the inconclusive for this study. We cannot conclude risk factor exposure in an objective manner since one-time observation is not enough. Selection bias is definitely present, and it is related to the prevalence bias selection of a population. Now, heading to talk about cohort studies. Cohort is a group of people that share certain traits of interest to the clinical research project. It is important to understand that we will have more than one observation in time. Along this series of petrified moments of time, portrayed in an overall picture, we can now assure that an eclipse got to be a total eclipse at some point along the astronomical phenomenon. And this conclusion can be supported by the evidence of multiple observations we did throughout time, which is the follow-up that can happen within a cohort design. Cohorts may be employed for quite different purposes in clinical research. We can measure variables like age in a population in order to identify the life expectancy from a cutoff age of our interest. We can also use a birth date as an independent variable to identify the polio rates for people that were born, let's say, around 1920s to 1940s. We can also identify the exposure to a risk factor like Ehlers-Danlos syndrome and the incidence of aneurysms throughout time. We can also follow patients with diagnosed high-grade glioma that was surgically removed, and we measure throughout time the survival rate after a gross total resection of these cases. One of the limitations within retrospective data obtention is that quite often the data source was not meant for the purpose of the study, whereas in prospective cohorts the data obtention is more accurate since it's executed accordingly to the purpose of the study. Retrospective cohorts will be useful for incidence and prognosis, and prospective cohorts can also provide us reliable information within risks and stronger associations that, with a well-performed statistical analysis, may also provide us a causality insight. Nevertheless, prospective cohorts can get to be overwhelming due to the high costs and the time investment along the follow-up. Okay then, case-controlled studies is the next observational design that we will briefly introduce. First off, we need to identify which are our cases and which are our controls. These studies aim to identify a relationship of certain factors observed within the disease and without the disease or the condition of interest, which is why you compare both groups in terms of these prevalent factors. Most of the case control studies are retrospective since you first identified the groups according to the effect of the developed disease or not. Now, let's say that Auntie Gertrudis is a biologist and she travels around the world looking at plants. And she finds out that in Mexico the leguminous plants are way taller than in Norway, where she usually lives. So she decides to do a case control study among leguminous plants where the Mexican plants are taller than in Norway and the amount of sunny hours during autumn season. She then compares both groups and concludes that the average height in Mexican leguminous plants is 9 centimeters. Meanwhile, in Norway they were around 5 centimeters. In Mexico they were exposed to 1080 hours of sunlight, while in Norway they were exposed only to 450 hours of sunlight. Then she concludes that the prevalence of sunlight may be related to the height growth of the leguminous beans. After this example, I would like to show you this case-control design illustration, and please note the direction of inquiry is being retrospective. In other words, the subjects are chosen based on their status as a case or control, and then the exposure status is determined for the aims of the study. Now, before we begin with another observational design, I would like you to identify certain differences between case control and cohort designs. Case control studies compare groups with and without disease or condition. Cohorts first identify the exposure and then observe if a disease or condition was developed or not, which is the incidence. Most case controls are retrospective since research question is basically what happened? Why are this plant species twice the size here than in Norway? Meanwhile, in cohorts, they can be retrospective or prospective or even bimodal. Case controls are quite affordable and straightforward. In contrast, cohorts are all the contrary and especially prospective or bimodal data obtention due to the time of follow-up. Case controls are suitable to compare rare diseases with controls, and cohorts are not meant for rare diseases, since it's not like you can wait 20, 30 or 40 years of follow-up to identify if your adult population with certain food allergies will develop eosinophilic colitis. This disease, which is quite rare, would be better approached in a retrospective manner with a case control design. On the contrary, cohorts are suitable best for common diseases or rare exposures that you may follow a long time and then identify the outcome or the incidence of resulting diseases. Now, let's head to the last observational design for this session, which is the case series. This design is pretty straightforward, where you just compile cases with a particular disease or condition, you observe them, and describe their demographic, environmental, and clinical characteristics. These studies will provide us an overall perspective of the population with that disease. They will increase the knowledge of the natural history of the disease, its clinical variations, and sometimes even a risk factor correlation may also be analyzed. These are studies that do not aim to be powerful evidence through complex research methodology, but will certainly portray insights to be aimed or to be assessed in future studies around the scientific world. So all in all, some of the take-home messages in wrapping up are the following. First, mind the time of data obtention. Cross-sectional is a one-time period of data obtention. Prospective cohorts does a follow-up in time-related tense, and retrospective cohort makes a follow-up or multiple data observations from present time to the past. Meanwhile, case control studies are likewise usually retrospective because you first identify the resulting effect or disease and then step back in time to find the related factors. And finally, I hope this diagram helps you wrap up the objectives of each observational design. And thank you very much for watching, and let me know if you have any additional comments or questions related to this topic on observational designs. This is Rodrigo Uribe, teaching assistant of the PPCR course 2023, and it was my pleasure to be here with you, and please have a great day. Ciao!